In this video, we're going to generate equivalent expressions using the associative property. The associative property allows you to group different sets of numbers together without changing the solution. Just like the commutative property, the associative property only applies to addition and multiplication. So again, we're going to explore that and prove that on the next slide. But the way that I like to remember the associative property is think about what we mean when we say people that you associate with. Those would be your friends that you associate with. And so you could think about them as being in your group. So the associative property reminds me that we're talking about grouping. And we see that we can group different sets of numbers in addition and multiplication without changing the value of the expression. Now let's prove that to ourselves by first looking at addition. So notice what we have here on the left. I'm again going to color code to show that we have the same variables on the left and the right of this equal sign, but they're grouped together differently. On the left of the equal sign, I've grouped P plus R, but then on the right, I have the variables in the same order. I've just grouped R plus S together instead. Now let's substitute these values in place of those variables to prove that this works and is true. So if P is equal to 12 and R is equal to 5, in that first expression I would have 12 plus 5 plus S, which is 2. And we're saying that that should equal 12 plus 5 plus 2, except this time the parentheses is around the 5 plus 2. Well, let's simplify the left and the right and see if these two expressions are equal. On the left, I would start with parentheses and I would simplify 12 plus 5, which is 17. Then I would add 17 plus 2, giving me a total value of 19. Now let's look at the right side of the equation, and we would first simplify what we see in parentheses because we're following the order of operations. So this would be 12 plus 7, and then 12 plus 7 is equal to 19. So we've shown that we can group different sets of numbers in addition, and we should still have equivalent expressions. What about with multiplication? So this time we have P multiplied by R and multiplied by S, but we have grouped different sets of numbers. On the left, we grouped P times R, and on the right, we grouped R times S. So let's substitute the values for these variables to see if we still have equivalent expressions regardless of how we grouped these numbers. So on the left, I'm replacing P with 12 and R with 5 and S with 2. On the right, I know that these numbers are going to be in the same order, but this time I am grouping the 5 times 2. So I'll simplify what I have on the left first. In parentheses, 12 times 5 is equal to 60. And then 60 times 2 is 120. Now the right side of this equation, I would first simplify what's in parentheses. So I'm going to copy the 12. And inside of parentheses, 5 times 2 is equal to 10. And then 12 times 10 is equal to 120. So again, we showed that no matter which groups of numbers we group together, or which sets of numbers we group together in multiplication, these expressions were still equivalent. So part B says, give an example to show why division is not associative. So let's think of 3 numbers here, and I'm going to show each of these being divided, and I'm going to group them differently and see if it gives me the same result or a different result. Here's what I mean. Let's say I have 8 divided by 4 divided by 2. And I'm first going to group 8 divided by 4, and I'll see what this equals. Then I will work it a second time, but instead of grouping the 8 divided by 4, I'm going to group 4 divided by 2. Well, in this first expression that I wrote, 8 divided by 4 is 2, and 2 divided by 2 is 1. So that expression has a value of 1. Now, in the second example, if I instead group 4 divided by 2, this means I would be dividing 8 by 4 divided by 2, and if I simplify that, that's 2. 8 divided by 2 is equal to 4. So because 1 is not equal to 4, we've shown that division is not associative. We can't just group whatever sets of numbers we want to and get the same simplified expression value. So great job. Now we know that the associative property applies to both addition and multiplication.